Okay, next law. Okay, so now we're in this area of the official classic gas laws. The gas law. The first one we look at is something called Boyle's law. I've often wished Boyle's law had to do with temperature and volume. It doesn't, because Boyle, that's easy to remember. Boyle is temperature, but it's not, so don't think that. Okay, all right, and basically Boyle's law just says this, that gas volume will vary inversely with the pressure put on the gas if you hold the temperature constant. And that's pretty intuitive, right? I'm gonna have a little video for you. If you take a gas in an enclosed container and you press it, you put more pressure on it, you will be able to decrease the volume, because gases are not very dense. They have a lot of space between them. All right, the mathematical way of saying this is like this, that pressure times volume is constant, where P is pressure, V is volume, K is a constant. We'll talk about what that constant is a little bit later. All right, now if we were to change the pressure on the gas in our container that we're talking about, all right? When we change that pressure, we get a new volume, because we know that the more pressure we put on a gas, the smaller the volume will be. It varies inversely. So what we get is this nice little equation right here. The first pressure multiplied by the first volume is going to be equal to the second pressure multiplied by the second volume. All right, you're going to have to know how to do problems using all of these gas law equations. So a quick look at a graph of Boyle's law is this, and we're seeing that as pressure increases, what is volume doing? As we go across here, volume's getting smaller. You can see that it's in not a straight line graph, but rather an exponential situation. But that is a graph of a gas with the pressure putting on the gas being changed over time. And you can see the volume is going down. Okay. All right. All right, I will show you this problem, because you do have to know how to do these for the test. So we have a sample of oxygen gas. It has a volume of 150 milliliters when its pressure is 0.947 atmospheres. What will the volume of the gas be at a pressure of 0.987 atmospheres if the temperature remains constant? Okay, so we have our P1V1 equals P2V2, and we're solving for which? We are given our first volume, we're given our first pressure, we're given our second pressure, and it asks, what will the volume be? So we're trying to find volume 2 here. So all I've done here is algebra to solve for volume 2. And this is what we get to solve for volume 2. We get volume 2 is equal to P1V1 over P2. And we just plug our numbers in after that. So first pressure is 0.947. First volume is 150 milliliters. And second pressure is 0.987 atmospheres. So we get our second volume is equivalent, and we just plug that in, do the math. Second volume is equivalent to 143.9 milliliters. Hopefully that's easily understandable. This is pretty easy math. That's the nice thing about the gas laws, is that they are pretty easy math. I'm not sure what this problem is about. My guess is it's some other problem. I just needed a space to do it. So let's just ignore this one. Focus on that. Make sure you know how to do that problem.